Hello, and welcome to the section on dilations. A dilation is a transformation whose pre-image and image are similar. And if you recall, with similar figures, corresponding angles are congruent and corresponding sides are proportional. So when we're talking about dilations, every dilation has a center and a scale factor. And then the scale factor is going to tell us the difference, essentially, or the changes that are being made from the pre-image to the image. So to look at an example kind of step by step, what we've got here is we're going to take this triangle ABC with the given vertices, and we're going to draw it and its image under what we call a dilation with a scale factor of 2. Okay, we're going to do this on the same coordinate plane. So the first step is going to be to draw the pre-image. So you can see right here we have our pre-image. Okay, and we literally just plotted the points ABC. Then what you're going to do is you're going to apply the scale factor. Well, the scale factor we know is 2, and what this means is we're going to multiply every coordinate, both x and y, by that scale factor. So we started out with a pre-image of 0, 0, 0 times 2, and 0 times 2 will still give you 0, 0. Then we're going to look at coordinate b, which is -1, 2. -1 times 2 will give me a -2. 2 times 2 will give me a +4. So I end up with a coordinate point -2, 4. And I'm going to do the same thing with point C, which is 3, 3. So I multiply both of those by 2 and I get 6, 6. So in step 3, what we're going to do is we are then going to go ahead and draw the image on the same coordinate plane, like what you can see right here. And the blue triangle is the same triangle, only it's scaled up by a factor of 2. So let's go ahead and take a look at an example on our own. And we're going to ignore the orange lines on the coordinate plane right now. They did not come through properly, but we'll still walk through this. So for example number 1, we have the triangle TRI, and we're going to draw the figure and its image underneath the dilation. So I'm going to start out by plotting T, R, and I. So we end up with something that looks like this. Then what I'm going to do is I'm going to apply the scale factor. So for coordinate point T, or actually I'm really going to look at T prime, if I take -5 and I multiply it by 2, I get a -10. -5 for my y value times 2 is a -10. Then I have R. R prime is going to still be 0, 0. And I have I prime, which is going to give me a -2 and a -6. So I'm going to go ahead and plot these points in. So I have -10, -10, 0, 0, and -2, -6 is right here. So this is now R prime. I have T prime, and this is I prime. And if I go ahead and connect these, you're going to see that you end up with something like this. Example 2 is similar. Here we have quadrilateral MNPQ, and they give us our vertices, so I'm going to go ahead and plot those. And I end up with something like this. Then, as you can see off to the side here, I've already done the math for us. Our scale factor here is 1/2. So with a scale factor of 1/2, that means that my image is probably going to be smaller because it's less than, or it's not at least the 100% mark. So when I multiply this, my M prime is still at 0, 0. My N prime gives me 1/2 and 2. So I'm going to be somewhere in here. And this is N prime. P prime is 2 and 2.5. And Q prime is 3.5, 0. So here we end up with a figure that looks something like this. Now for our final example today, we are going to look at the two figures and try to figure out what the dilation is. So ultimately what we're going to do is, it says the blue figure is the dilation of the red figure. Or in other words, the red figure is the original image, the blue figure is the new image, so we have to figure out what that scale factor is. So for part 1, you can see that we are going, the blue factor is bigger, so we have a 6/4, because I'm looking at my corresponding side lengths. So 6/4 is going to give me 3/2. When I look at my number 2 here, the blue figure is the second figure, and I can see that that's 9, and I'm going to divide that by 3, so I get a scale factor of 3. For number 3, I have, now it doesn't give me my total size or side length up to the blue, but I can see that this right here is really going to be 4 plus 2, which is 6. And the blue image is bigger, so this is going to give me 6 divided by my original height, which is 4, or 3/2. For number 4, if I look at one of my side lengths here, let me change my color. So here you can see that this is a 2, and if I go to the next size bigger, like this whole side length, and I'm just going to write this up here, is 6. And now when I look at my blue figure is actually smaller. So because it's smaller, I'm going to end up with 2 divided by 6, which is really 1/3. Likewise, for number 5, my blue image is smaller, and I'm just going to pick one side length, and it doesn't really matter. But if I take and I look at this length right here, I can see that that's really a 1. And if I look at the same corresponding length, I can see that that's 1, 2, 3. So that's 3. And because the blue is smaller, I'm going to put my 1 on top, and I really end up with a dilation of 1/3. Likewise, if I go to number 6 and I look at my blue image, and I'm just going to look at this side here, I've got 1, 2, 3, 4. To where right here, I only have 2. The blue image is bigger, so that's 4/2. And in this case, I end up with a dilation of 2. For number 7, we have the blue image is smaller, and that's 2. And then my red image has 1, 2, 3, 4. So this here will give me a dilation of 1/2. And I'm going to look, I like nice straight lines, so I'm going to use my blue side length here of 1, 2, 3, 4. And then if I look at the corresponding one here, I can see that that's 2. So this is 4/2, or a dilation of 2. And then for my last one, I'm going to look at these side lengths here. So for the red, I have 2. When I come out here and I look at the blue, I can see that the blue is actually going to be 3. The blue is actually bigger, and I have 3/2, which is 1/2, and that makes sense that it is bigger then. Please let me know if you have any questions. Otherwise, I hope you guys have a great day.